In this video, you will learn how to solve for x in this exponential equation. Now, to solve for x, you must remember that the value of 9 can be equal to 3 multiplied by 3, and the value of 6 can be equal to 3 multiplied by 2. So, if we apply that to this equation, we're going to have x to the value of 3 to the power of 3 all to the power of 3 plus x to the power of 2 or 3 all to the power of 2, and this will be equal to 36. Fine. So having done this, we will now have to assume, or we'll let x to the power of 3 to be equal to m. So if we let x equal to the power of 3 equal to m, we're going to have this part of the equation to now become m to the power of 3 plus this will become m squared, and that will be equal to 36. So if we subtract 36 from both sides, this equation will now give us m cubed plus m squared minus 36, and this will be equal to 0. Fine. So we are going to simplify in order to get the value of m. But in order for we to simplify for that, don't forget to give this video a thumbs up and also subscribe to our channel for more of our videos. Now, in order to simplify this, all we are going to do is to assume something. Let's assume that negative 36 is equal to minus 27 minus 9. And minus 27 minus 9 will give us 36. So we are going to simplify this expression further. M cubed plus m squared minus 27 minus 9 will be equal to 0. Fine. So we'll have m cubed minus 27 plus m squared minus 9, and this will be equal to 0. Now, if we simplify this, we are going to have m cubed minus, this will be 3 to the power of 3, right? Plus m squared minus, this will be 3 squared, and this will be equal to 0. Now I want you to recall two laws of indices of algebraic formulas. From that algebraic formulas, we will have a to the power of 3 minus b to the power of 3. This will be equal to a minus b, and then we'll have a squared plus ab plus b squared, right? And then if we have a squared minus b squared, this can be equal to a minus b, and then multiply by a plus b. So we're going to apply these two algebraic formula to that expression above. So if we apply that, we will have that expression to now give us, the first one will give us m minus 3, right? And then we'll have the second expression to now give us m squared plus 3m plus 3 squared, right? Good. And the other expression will now give us a positive sign m minus 3, right, multiplied by m plus 3, and all these will be equal to 0. Now you come to see that we have two expressions, m minus 3 and m minus 3 common. So we're going to bring out m minus 3 as a common expression, and then if this whole expression divides m minus 3, we're going to have m squared plus 3m plus 9 remaining over here. And if this whole expression divides by m minus 3, we're going to have plus m plus 3 remaining, and all these will be equal to 0. Fine. So if we simplify that expression, remembering that m minus 3 is equal to 0, that's the first expression we'll get, and then we'll have m squared plus 3m plus m will give us 4m, and then we'll have 9 plus 3 will give us 12. That will give us plus 12, and this will also be equal to 0. Great. So we'll now solve these two expressions in order to get the value of m. As we solve these two expressions, from the first expression, m minus 3 will be equal to 0. So our m will be equal to 3. That's the first real solution to the first expression. Then the second expression, we're going to have m squared plus 4m plus 12 to be equal to 0. From that polynomial expression, we're going to have two factors or two solutions from this quadratic equation. So to solve this, let's first of all test to see if this solution will give us real values or imaginary values. Let's look at find the discriminant of this value. The discriminant of this equation will give us b squared minus 4ac. So having a to be equal to 1, b to be equal to 4, and c to be equal to 12, we can simplify that expression. So the discriminant will now be equal to 4 squared minus 4 multiplied by 1, 4 multiplied by 1 multiplied by 12. So this will be equal to 4 squared is 16 minus 4 times 12 is going to give us 48. So our discriminant will now be equal to 16 minus 48 will give us a negative 32. So if we look at negative 32 is actually less than 0, so that tells us that the solution to that quadratic equation, if properly solved, will give us imaginary solutions and not real solutions. As a result of that, we are going to neglect this solution. So the only real solution we'll have for this expression is m equal to 3. Now recall from the initial expression, we have the fact that x to the power of 3 is equal to m. So if we apply that to that expression, we're going to have, recall, we'll have x to the power of 3 to be equal to m. So x to the power of 3 will be equal to 3, right? So to find the value of x, we are going to take the cube root of both sides. We take the cube root of this side, x to the power of 3, and this will be equal to the cube root of what? Of 3. So this part will give us x to be equal to 3 to the power of 1 divided by 3. Recall that the cube root of any value will be equal to that value to the power of 1 divided by 3. Fine. So x to the power of 1 divided by 3 is the solution that satisfies that exponential equation above. Now let's do something. We want to check if this solution is absolutely right. So our initial expression is x to the power of 9 plus x to the power of 6. Will it actually give us 36? Now let's try this out. X to the power of 3, that will give us 3 to the power of 1 divided by 3, all multiplied by 9 plus 3 to the power of 1 divided by 3 multiplied by 6. So according to the law of indices, the internal exponent will multiply the external. So we'll have 3 to the power of 1 divided by 3 multiplied by 9, right? Plus 3 to the power of 1 divided by 3 multiplied by 6. So this over here will give us 1 and this will give us 3, right? This will give us 1 and this will give us 2. So we'll have 3 to the power of 3 plus 3 to the power of 2, and this will be equal to 27 plus 9, right? And 27 plus 9 is equal to 36. So you see the value of x equal to 3 to the power of 1 divided by 3 truly satisfies that exponential equation found above. So thanks so much for watching, and don't forget to share this video with your friends and colleagues. I look forward to seeing you watch our subsequent videos. Bye bye for now.